Hello everyone, welcome back to my YouTube channel. In today's video, we are going to discuss about most important questions of Dbms. In this video, we are covering Unit 1, 2 and 3. These are the questions which are mostly comes in your exams. So let's start. These are the 2-mark questions of Unit 1, which is Introduction and ER Models. So the first question will be define data independency. The second will be what is the difference between schema and an instance. List 3 levels of Dbms architecture and define derived attribute with an example. So let's understand these questions. The first will be define data independency. So data independency is the ability to modify a schema definition in one level without affecting the schema definition of next level. So these are in two types: physical data independency and logical data independency. In physical data independency, modifying the physical storage without changing the logical schema, and logical data independency will be modifying the logical schema without changing the external view. So this is data independency. The next question will be what is a weak entity. So with example, an entity that does not have a primary key of its own and depends on a strong entity for its existence, this is known as weak entity. Example will be dependent, like family members of an employee. If the employee leaves the company, the dependent data is removed. It is represented by a double rectangle. So this is weak entity. The third question will be differentiate between schema and instance. So schema will be the logical design or skeleton of database, example table or structure. It rarely changes, and instance is the actual data stored in the database at a particular moment, or the snapshot, right? So it changes frequently. The last question of this will be what is derived attribute. So an attribute whose value is calculated or derived from other attribute, that attributes are known as derived attributes. Example, age is a derived from date of birth. In ER diagram, you can represent using ellipse. The next questions will be long questions that comes in your exams like 7 marks or 10 marks. So these are the questions of Unit 1. Explain 3 schema architecture of Dbms. Why do we need it? The second question will be file system versus Dbms. So we have to differentiate between them. 5 major advantages of Dbms also we have to say. And the third question will be draw an AR diagram for university management system, like explain entity, attribute and relationship. We have to explain these of them. And the fourth question will be specialization, generalization and aggregation with suitable example. So let's understand these questions. The first question will be explain the 3 schema architecture of Dbms. So this schema architecture, also known as NSI or Spark architecture, divides the database into 3 levels to achieve data independency. The first one will be internal level, like physical schema, describes how data is physically stored on disk, deals with data compression, hashing and storage paths. The second will be conceptual level, like logical schema, where it describes what data is stored and relations between them. This is where the DBA defines entities, attributes and constants. So these are the conceptual level of 3-level architecture. The third level will be external level, which is view schema. This is the highest level and it describes how only the part of database relevant to a specific users, like different users, account versus student. So these are the 3 schema architecture of DBMS. The next question will be we have to differentiate between them. So on the basis of comparisons, we differentiate file system and database system. So first comparison will be based on structure. So file system, where data is stored in a hierarchical and flat file structure, and in DBMS data is stored in table like relational or objects. When we talk about on the basis of redundancy, high redundancy in file system, multiple copies of same data often exist. And we talk about DBMS, low there is low redundancy, like centralization minimizes data duplication. The third basis of comparison will be consistency, where the file system have low because updating one file doesn't update other automatically, and in DBMS there is high. One update deflects other to entire system. So this is the uh, basis of comparison differentiate. Like when we on the basis of data sharing, very high in files, very difficult in file system. Files are as isolated and hard to link, where in DBMS easily multiple user can access data simultaneously. When we talk about security, file system having basic like limited to file level passwords, and in DBMS there is security will be high, offer granular access user versus admin. The next one will be on the basis of transaction. File system no support for asset properties or complex tasks, but DBMS full supports for asset properties, which allow transaction successfully and securely. The last comparison will be on the basis of recovery. In file system, manual and difficult, so high risk of data loss, but in DBMS automatic, like uses logs and checkpoints for safety. So these are the differentiation between or comparison between system versus DBMS. The next question will be explain the component of an ER model with notation. So let's talk about what is ER model. So ER model stands for entity relationship model. It is very high level conceptual data model where we represent the relationship between the entities. So the components will be entity. The first component will be entity. An object in the real world will be known as entity, and we represent them in a rectangle box. When we talk about next component, which is attributes. So attribute is basically properties of an entity, and we will represent this as a eclipse. The next will be simple, simple atomic values like gender. When we talk about composite, can be divided, example name, which is first or last. The next will be multi-valued, which means can have multiple values, example phone number. So this is the third question. Let's talk about question number 4, which is explain generalization, specialization and aggregation in EER. So let's talk about this. These are used for complex database requirements. What is a specialization? Basically a top-down approach where breaking a higher level entity into lower level entity, like employee, technician, engineer, accountant. So we break them into different categories. The next will be generalization, which is bottom to approach where combining lower level entities into higher level entity. So in this entity based on the common features like car, so car and truck, vehicle. The last one will be aggregation, where a process in which a relationship between two entities is treated as single high level entity to participate in another relationship. So these are the generalization, specialization and aggregation of unit 1, which is of maybe considered in 7 marks or 10 marks. So all these are the important questions, maximum they are asked in your exams. Let's talk about unit number 2, which is relational model and SQL. These are the short questions, like 2-mark questions, which are mostly come in your exam. So the first question will be, what is referential integrity? Define tuple and cardinality. What is foreign key? Or they may talk about any type of key, like they may ask any type of key. All right, so you have to understand about keys and differentiate between delete and truncate command. This is the most important question. So let's understand these questions. The first question will be relationship model. All right, okay. So a domain is a set of atomic values that are in this question we understand what is domain. All right, this question also comes. So a domain is a set of atomic values that an attribute can take. So it defines the data type or range. Example like gender, the domain will be male, female, other. Like age, domain will be integer value, like any value from 1 to 100. When we talk about entity integrity and referential integrity, so integrity is basically the rules or values. So entity integrity is basically the primary key of a table cannot be null. So this is entity integrity. Every row must be uniquely identified, so primary key is necessary. The referential integrity will be the foreign key in table A must either matches primary key of table B or be null. So it ensures no often records exist. So this is differentiate between them, or definition we can say. The third question will be, what is difference between delete and truncate. So delete will be a DML command, like data manipulation language command. It deletes the specific row using where clause, where specify where you want to filtering the rows, मतलब what rows you want, and can be roll back. And truncate command is basically a DDL command, so data definition language command, where it deletes all rows from a table. So there we delete specific row, and truncate will delete all the rows of a table instantly and reset the identity and cannot be easily rolled back. So these are the difference between delete and truncate. The last question will be of 2 marks will be define tuple and cardinality. So tuple is a single row in a table representing a record. So basically we can say rows are known as tuple, and like total number of cardinality is total number of rows. So this is so confusing, but you have to remember always tuple and cardinality. Okay, so tuple will be a single row in a table, and cardinality will be the total number of rows or tuples in a table. There is not written what is foreign key. So foreign key is basically a key is which connects two table. Like if a foreign key of table A will be there, then the foreign key then the prime it must matches to the primary key of another table, like referential integrity it shows there. So a foreign key in table A must either matches the primary key of table B. So this is known as foreign key. Let's talk about 7 or 10 mark long questions. The first question will be explain various type of join in SQL, like inner, left, right, full, with syntax and examples. And the next question will be what is relational algebra, like selection, projection, union, and join operation. Third question will be differentiate between DDL, DML, DCL with at least 2 commands for each. And the fourth question will be explain rational calculus like tuple and domain and how it differ from rational algebra. So let's understand these questions. The first question will be rational algebra operations with examples. So rational algebra is a procedural query language. It uses operations or operators to perform tasks. Like the first operation will be select, where used to filter rows based on a condition. So this is used to filter rows. Like you may ask in MCQs also in any exam, like computer based exam where SQL is present. So this will be select is used to filter the rows, and example will be you use sigma or select. The project will be projection, where we select or like used to select specific columns and eliminate duplicates. So there we will use pi. All right. Union is used to combine rows from two tables, so must have same schema. And set difference will be represented by minus, which is finds tuple in a table A that are not in table B. So it differentiate tables. And Cartesian product will be combine every row of table A with every row of table B. And we have joins like combines related tuple from two relations, like joining the rows of two relations. So these are the operations of relational algebra with examples. The next question will be explain different type of joins. So joins are used to combine row from two or more tables based on a related column. And we have inner join, left join, right join, and full join. So the inner join will be return records that have matching value in both tables. Left or outer join will be return all the records from the left table and matches record from the right table. The right outer join will be written all the records from the right table and matched records from the left. And full outer join will be written all the like records when there is a match in either left or right table. The last join will be self join. A table is joined with itself. So these are the types of join. You can also make a flow chart, or you can represent diagrammatically. The third question will be explain SQL data type and constraints. So the SQL data types, like to create table, we must define what type of data goes in and what. So rules are known as constraints. So constraints are basically the rules which are used to create or manage the database that are as follows. So let's talk about data types. So we have first data type will be int, which is a number integer type. Varchar, which is like we have, when we use varchar, we have to specify a number inside it, inside parenthesis. So for variable length string we use name address, so we can specify like name will be of 10 characters, 20 character, address will be of 100 characters, so we specify inside varchar. The decimal p comma is basically from starting value to ending value, like from for a number with decimal, salary, marks, etc. For date we have like YYY and MM and DD. So this is the format which is used for date. So this is, these are the data types. Let's talk about constraints. So we have primary key, like which is unique key, which identify each row uniquely and must they cannot be null, like not null values are not there, and unique like all value must be different and not null. These are the characteristics of primary key. And check ensure value meet a condition, like check is also used there for checking the conditions inside the query. And we have default, provide a value if none is entered, so here we use default. The fourth question will be compare relational algebra and relational calculus. So this is the table where we differentiate both of them. So on the basis of nature, we differentiate algebra as a, this is procedure like step by step, and calculus will be non-procedure like declarative. The approach is used in relational algebra basically defines how to obtain the result, and in relational calculus define what result is required. All right. So this is in relational algebra. Language type will be mathematical or operational, and in relational calculus we have logical and functional. When we talk about operation type, we have select, projection, as we study in the previous question. And in relational calculus we have logical quantifiers like for all, exist. These are the relational calculus, as we also use in queries as well, to like filtering the or to retrieving the data, what data we needed. So the next comparison will be on the basis of execution. So the order of operation matters and the order does not matter, that system decides. And the last comparison basis will be relation to SQL. So forms the basis for the query optimizer and forms the basis of the user written SQL query. So these are the comparison between relational algebra and relational calculus. Now let's talk about the unit 3 questions, which is not, which is the unit 3 will be normalization. So let's talk about them. These are the 2 mark questions. What is functional dependency? So this is important. Define atomic value, and what is transitive dependency, and why do we need normalization? So these are the questions of 2 marks, mostly comes in your exams. Now let's talk about them. The first question will be, what is functional independency? So basically it is a constraint that describes relation between attribute in a relation. Like if attribute A uniquely determined attribute B, like B, we write it as A to B. So this is functional dependency, means a attribute depends on the another and make a relationship between them. Like we take example roll number to name. So if you know the roll number, you can find the unique name now. So this is functional dependency. You can explain with a single example as well. The next question will be define term like anomaly, like atomic value. So what is anomaly in DBMS? So anomalies are problems that basically poorly designed databases during data operations, like insertion anomaly, deletion anomaly, and updation anomaly, like cannot add data because some other data is missing, loss of undocumented data during deletion, and data inconsistency caused by redundant data. The next question will be, what is trivial function dependencies? So a function dependency x to y is trivial if y is a subset of x, like roll number and name to roll number is trivial because roll number is already part of the left side. The last question will be, what is the difference between 3NF and BCNF? So this is important question. BCNF is basically a stricter version of 3NF, and a table is in BCNF if for every functional dependency x to y, x is a super key. In 3NF, y could also be a part attribute, which BCNF does not allow. These are the questions which I am not saying. So like why do we need normalization? So we need normalization because when we break the tables, it maintain the redundancy and consistency, or as well as integrity of the table as well. And atomic values are basically one value will be entered at a time. or a single function will be execute at a time. These are the long questions which is of 7 marks. The first question will be explain 1NF, 2NF, 3NF with step-by-step example of a table with being decomposed. Second will be 3NF, BCNF, why BCNF considered stronger, and what are update, insertion and deletion anomalies, like explain with example as I explained earlier question as well for 2 marks, and explain multi-value dependency and fourth normal form. So let's understand. The first will be 1NF, 2NF. So let's talk about normalization is a process of minimizing redundancy, as I told. And when we talk about 1NF, which is first normal form, the rule will be attribute must be atomic number. Multi-valued attributes are nested tables. So this is the example. A phone column cannot have two numbers, like number will be a single atomic value, and you must split them into two rows. The second will be 2NF, which is second normal form. Rule will be must be in 1NF and no partial dependency will be there. So all non-prime attributes must depend on the whole candidate key, not just part of it. The third will be 3NF, which is must be in 2NF and no transitive dependency is there. So non-prime attributes should not depend on other non-prime attribute. If A to B and B to C, then A to C is transitive dependency that must be removed in this. The next question will be what is losses, like lossless join decomposition and dependency preservation. So let's talk about them. When we split a big table into smaller table like decomposition, we must follow two properties. The lossless join will be if we join the decomposed table back using a natural join, we must get the exact original table without any spurious like extra fake rows. When we check that the common attribute between table must be an candidate key, like the keys which are selected for becoming a primary key. So these are the candidate key and it at least one of the table. And when we talk about dependency preservation, so all original functional dependencies that exist in the big table must still be present or covered by the new smaller table. If we lost a dependency, we cannot enforce that business rule anymore. So these are the lossless join decomposition and dependency preservation. The next question will be explain multi-value dependency like MVD and 4NF. So multi-value dependency is basically occurs when one attribute determines a set of values in another attribute and those values are dependent of other attributes. Like example, a teacher teaches many students and speaks many language. So subject and language are independent of each other but both depend on teacher. So this is the example of multi-value dependency. Let's talk about 4NF, which is fourth normal form. So a table is in 4NF if it is in BCNF and contain no multi-value dependency. Like to move to 4NF, split the independent multi-valued attributes into two separate tables like teacher and subject or teacher and language. So these are the MVD and 4NF. The last question of this video will be how do you find candidate key of a relation? So let's talk about this. This is a logical process which is used in your exams. You have to use them like identify the FD. You have to look at given functional dependencies and closure method like X plus. Find the set of all attributes that can be determined by an attribute X. Alright, the rule will be if you closure of an attribute like contain all the attributes of the relation, then that set is known as candidate key. Like you have to find the attributes which are depend on or determined by the X. Like X is to A, B or X is to D, C, D. So you have to collect all of them and then contain all attributes of relation and this set is known as candidate key. Example, we have ABC where A to B and B to C there. So we take A plus like A closure, A, B, C, and since it contains all attributes, A is the candidate key. All these are the unit 1 to 3 most important questions. If you like this video, thanks for watching. Thank you so much.